Okay, hello everybody. Hope everyone is safe. I had one of the students sent me an email asking me for some help on one of the exercises, section 4-3 in the exercises, and that was problem number 7, and that's page 222 of the uh, edition that we're using, which is edition number 10. Now, some of you are using a previous edition, and I don't know what page number it's on, but hopefully it's roughly speaking the same. Okay, so here we go. This took a little bit of effort, and I wrote it out in excruciating detail because I think it might be helpful for you. So the way I recommend you do this, I recommend that you try the problem yourself. Spend at least 20 minutes, 20, 30 minutes on the problem on your own. Try to figure it out, okay? And then if you are having difficulties, go ahead and look at my solution. But don't just read my solution and say, oh, well, I understand that, and therefore that's good enough. Remember, I've talked about this in class. The stages of learning. You recognize things, you are able to repeat things, and then you're able to restate things. So there are 3 R's. The recognizing things means you just understand. Well, you're going to probably understand it when you see it, okay? But that's not good enough. You've got to be able to repeat it. You've got to be able to explain it to somebody else. And then the restating or restructuring means you can apply it to your own problem. So instead of being a problem like we have here where we're talking about personnel, maybe it's talking about something else, like it's talking about the coronavirus or a biology class or an economics class or whatever, okay? So there's an infinite number of applications. So take my advice on this, try it yourself, and then you can go ahead and look at my problem, my solution to assist you. Okay, so here we go. I'm going to let you read the problem yourself in the book. I didn't write all the details down. I didn't write it down on my paper. Here's my advice again. Take my advice on this. Have a structure. The structure I always use is I start out with given. I write down what it is that I am given. What is the information that I'm given? And then I'll write down what it is I'm supposed to find. Then I'll typically write down some sort of a discussion, and then I'll finally write down what the solution is. If you do it this way, I think you'll be happy, a lot happier in the long run. The biggest problem that people have typically is they will just look at the problem over and over and over again. They'll read it and read it and read it. That's a waste of your time. Read it only long enough to where you can write down what it is that you're given and write down what it is that you're supposed to find, and then close the book. Don't keep reading the problem over and over again. It leads to frustration. Okay, so here's what we're given. 66% of the law enforcement officers, or I'm sorry, let me say that again. 66% of the law enforcement workers were sworn officers. Item number 2, of these sworn officers, 88.4% were male. The female make up 60.7% of the so-called civilian employees. And what I said here is that the author is a little bit ambiguous here, because when he says civilian employees, what he's really talking about is the non-sworn officers. Okay, so that's the information that we're given here, okay? That's it. That's all we're given. We have to figure everything else out that we need by ourselves. Okay, so now the next step, find. Okay, here's what the problem is. Take one law enforcement Okay, I made a mistake here. I just observed. It says I wrote down take one law enforcement officer at random and find the following. Well, that's wrong. It's not one law enforcement officer. It's one law enforcement worker. There's a difference between just the officers and the civilians. So what I'm going to do is I'm going to take a break here. I'm going to fix this. I'm going to rescan the document, and I'll put a corrected version up. So give me a second. Okay, so I made that correction here. So here's what we're supposed to find. Take one law enforcement worker at random and find the following. So we don't know whether this person that you're taking is an officer or is a as a civilian. Is he sworn or is he not sworn? We don't know that yet. Okay, so the first problem, A, so there's A, B, and C. There's three problems. Problem A, find the probability that this worker is a female sworn officer. Okay, so this problem, what I'm trying to do here in this discussion, and this, I swear to you, I do this whenever I do my own homework problems at my own classes that I am taking all the time. I have this discussion. I talk to myself. I explain things to myself. So here's my discussion. This problem is an example of the multiplication rule number 1 that's on page 213 of the 10th edition. And here's the rule in summary. If some events, A and B, are independent, so remember what independent means. It means that A does not affect B, B does not affect A. So if event A and B are independent, the probability of both of them occurring, here's how we write it. The probability of A and B is equal to the probability of A times the probability of B. Okay, so anyway, go back to that page 213, back to 213. Take a look at that rule. Make sure you understand the rule, because that's what's going on here. It's a multiplication rule number 1, where you have independent events. Now, obviously, the first question is, why are these independent? Okay, well, they're independent because the fact that the person is a female does not dictate whether they're a sworn officer or not. The fact that they're a sworn officer does not dictate whether it is a female person or not, right? They're independent. So the scenario here is we're picking somebody at random. Everybody has an equal chance of being picked, but there's probabilities associated with them, of course. But they're all kind of in a box, and you're reaching in there. And it's just like having, 20 balls in a box, and you reach in and 19 of them are red and one of them is blue. Well, there's a different probability of picking a red than there is of picking a blue, but every ball is equally likely to be picked out. Okay, you reach into the box and you pull it out. Well, that's what's going on here. You pick somebody at random from the employees. Okay, so the first thing we note is we can figure out the stuff that we need based on what we're given. So it says up here that 88.4% were male. So of the sworn officers. So if 88.4% of the sworn officers are male, well, figure it out. How many of them are female? It's 100 subtract 88.4, so that's 11.6% are female sworn officers. So we're figuring that out from the given information. Okay, so as I was doing the problem, later on I started doing some scratch work, and I didn't have time to rewrite everything. So I put a little note here, see the next page. So let's go to the next page. What I've got here is I've got a tree diagram. Now, hopefully you've taken a look at these in the book. I hope you have. The tree diagrams are very helpful, okay? They help us visualize things and kind of figure things out. So let's take a look at this. We're picking this employee. Out of the sworn employee, out of all the employees, or all the workers, 66% of them are sworn. 34% of them are civilian. So if you're trying to figure out what are the chances of someone being picked at random, that's, for example, a sworn female or a sworn male, well, how do you do it? It's exactly like we had before. Remember, I told you at the time, the examples are just like metaphors, just to help us figure things out and to understand things. So we had a metaphor, we had a problem before of I flip a coin, then I toss a dice, right? Who the heck would ever do something like that, right? But, well, it's a metaphor to help you understand it. Well, now we have a problem where it does make sense and it does help us. This is like tossing the coin. You get a head or you get a tail. These are like tossing flipping a coin again, or tossing a two-sided dice, or whatever you want to call it. Do you see what's going on here? The chances of getting somebody at random, getting that they're a sworn male, those are two independent events. So it's 66% times 88.4%. The chances of getting a civilian female, let's say, well, is a 34% chance of getting a civilian, and then after that, there's a 60.7% chance of getting a female. So these tree diagrams are actually very helpful. Another thing I decided to draw was just to help me visualize things, because you read the words and the words kind of get in the way. You're having a hard time understanding it. So this is kind of a modified Venn diagram. This rectangle here is the entire universe. Okay, the first thing they tell us is that of this, there's the sworn workers, there's 66%. So the civilian is 34%. Of the 66% that are sworn, 88.4 are male, 11.6 are female. Of the civilians, 60%, 60.7% of these guys are female, 39.3% therefore are male. So this helps you visualize things, okay? So that's the purpose of the tree diagram and the Venn diagram, is just to help you visualize. Okay, so let's go back up here. All right. So this is my discussion. This is, where I kind of put together, what are the appropriate formulas, figure out things that I need to figure out, and now I'm ready to do the solution. So it's given, and then it's find, and then it's solution. So to pick a female sworn officer, we note the two events, A and B in this case, okay, female and sworn, are the two events that we're talking about in our formula. A is being a female, B is being sworn. So that's what we have right here, the female and sworn. That's exactly, we're using the formula basically. So the probability of female and sworn is the probability of female times the probability of being sworn. That's exactly what the multiplication rule number 1 says. So probability of being female is 66%. Probability of being sworn is 11.6%. Okay, that comes from the given information that we had. I'm only going to do this one time, bouncing back and forth. Okay, so the 66% comes right from what we're given. The 11.6% comes from the fact that out of these sworn officers, okay, I'm sorry, I had to pause there for a moment, so I may be repeating myself. So 66% of the law enforcement officers were sworn officers, and then we get the 11.6%. That comes from the fact that 88.4% of the sworn officers were male, and that's how we came up with this business here, where we said that 88.4% are male, therefore 11.6 are female. Okay, so putting it all together here, I switched the order here, but that doesn't matter because, multiplication is commutative, right? You can put it in any order you want. So the probability of picking a sworn person is 66%. So probability of picking a sworn person is 66%. The probability of picking a female person is 11.6% out of those sworn people. So you pick the sworn person, and then 11.6% of them are female, multiply that together, and boom, there's your answer. So it's 0.07656, or roughly speaking 7.5%, 7.6% probability of getting a sworn female. Okay, then as I said, this is the diagram. That's the tree diagram. Here's the Venn diagram. Okay, so problem number B. So we're going to talk about problem number B. So what I'm going to do is I'm going to end this video. This will be video number 1, and then on the next video I'll start with this problem right here. So this is the end of the tape.